Hello, welcome to class today. In today's class, we are going to talk about evaluating logarithms. If you are new to this class, check the description link below. You are going to see the other links of the theory of logarithm that have been explained. While in this class, we want to solve some questions based on what we have discussed in the previous class. And in so doing, we are going to see what we have here and see how we are going to solve it using the concept and application and the theory of logarithm that has been discussed. Now, the first question we are having here is log 81 base 3, log 0.0625 base 4, log 32 base 8, log 0.5 base 32, log 128 base 0.25, and log root 128 base 2 root 2. We are going to see how we are going to solve this question step by step. And we are going to be using some other approaches to see how we can solve it, aside from probably using more than one method, so that you can have understanding and decide on which method is suitable for you while studying. Now, let's look at how we are going to solve this. Now, the first question we are having there is log 81 base 3. Please sit tight and enjoy yourself while you listen to how it is being solved. Now, the first one is you're having log 81 base 3. Now, for you to solve this, you are going to let this value to be equal to the unknown. Now, you can say let log 81 base 3 equals to y. Now, if you have written something like this, this is a logarithm form. Then you can write logarithm form in index form. And what do I mean by that? If you are given log of number n to base a to be equals to x. Now, this is your base. This is log n base a equals to x. And if you want to express this in index form, this is still your base. So you are going to write your base a. That means what number will be raised to the power of a to get n, and that is our x. That means a is raised to the power of x, and that equals to n. A raised to the power of x equals to n. So what we have here is what we call logarithm form, and what we have here is what we call index form. Now, this is your logarithm form, and this is your index form. Now, you can write the same thing that you have here. This is log 81 base 3 equals to y. You can write it from logarithm form to index form. Now, let's do the comparison here. You can see that you're having 81 here. 81 stands for n, and a stands for 3, while your x stands for y, as you have it here. So if I want to write it in index form, the way I have it here, then I'm going to have, this is my base, that's 3, and that's where a is standing. 3 raised to power, you can see y here, 3 raised to power y to be equals to 81. So if you are able to write it on this level, you have written log 81 base 3 equals to y as 3 raised to power y base 3 raised to power y equals to 81. So from here, you can solve this using your indices knowledge. Now, how do you do that? You can simplify 81 as the base of 3. That means how many times will you multiply a number to get 81? Same number. And that is the number you can multiply by itself and on to get 81 is 3. That means I can rewrite 81 as 3 raised to power y equals to 81 is going to be 3 raised to power 4. That means 3 in 4 places. That means when you have your 3 times 3 times 3 times 3, 3 times 3 is 9, 9 times 3, 27, 27 times 3, this gives us 81. So I'm writing this in index form, 3 in 4 places. That's why I have 3 raised to power 4. And that is 81 equals to 3 raised to power 4. This is 3 raised to power y equals to 3 raised to power y. Then from here, since we are having the same base, we are going to say equate the powers. Equate the powers. Now, when you equate the powers, that means y equals to 4. Y equals to 4. As you can see it here, y equals to 4. I hope you understand the method and how it is being solved. However, you can still solve this logarithm form using another method, as I've discussed with you. Now, how do you solve it using other method? In the other method that we have here, we are going to have the number as it is. That means we are only going to have log 81 base 3. Then you can see I can rewrite my 81 as the power of 3, just like what we have here, 3 times 3 times 3 times 3. Then I can rewrite this as log 3 raised to power 3, 3 raised to power 4 base 3. That's 3 raised to power 4 is 81 base 3. Then from here, how am I going to solve this? Now, there is one of the law of logarithm that says that when you're having log m raised to power p base a, this equals to p log m base what? A. That means if I have this number as it is now, this is p log m base a. That is when you're having log m raised to power p base a. So I can relate what I have here with what I have in this place. And in so doing, I'm going to have 4 log 3 base 3. Now, another law that we are going to apply here is the fact that when you're having the number and the base, one of the identity of logarithm, log a base a is equals to 1. Log a base a is equals to 1 because a raised to power 1 will give us a. So when you're having log 3 base 3, that also is going to give you 1. So that means that log 4 log 3 base 3 is going to be 4 times 1, and the answer is what? 4. You can see whichever method you use, if you apply this method, you get your answer to be 4. If you apply this method, you get your answer to be 4. I hope you understand that. Now, let's see how we are going to solve the second question based on what we have there. Still using the two methods to solve the question. Now, let's see how we are going to solve that. Now, in the second question, we are having log, this is now log 0.0625 base 4. Log is 0.0625 base 4. How will you solve or evaluate this? Now, you can say the same thing that let log 0.0625 base 4 equals to m. Now, in this case, you can express this number in logarithm form, in our index form. And how do you do that? This is our 4, which is the base. That means we are going to have the base as 4. We are having 4 as the base. Raised to power n is equals to 0.0625. And from here, if you're having 4 raised to power m equals to 0.0625, then how are we going to express this in decimal? Now we are going to convert what we have in decimal to fraction. And in that case, I'm going to have 4 raised to power m to be equals to 625 divided by 10,000. As you can see, this is 1, 2, 3, 4, 4 zeros. That's 10,000. So how do you go about this? 25 goes in 625. That's 25. 25 times 25 will give us 625. 25 goes in 100. That's 4. Then in 0 is 0 is 0. So we are having here as 25 over 400. Also, we are still going to divide further. Now, when you say 5 goes in 25, that is 5. 5 goes in 40 is 8. In a 0 is 0. Then we can still go further and say 5 goes in 5 is 1. 5 goes in 8 is 1. Remainder 3. In 30 is going to give us 6. So, therefore, we can say that 4 raised to power m is equals to 1 over 16. Now, 1 over 16. From here, 1 over 16 can be rewritten. You can write it as 4 raised to power m is equals to 16 raised to power minus 1. Your index. When the 16 come up, 16 raised to power minus 1. Then you're having 4 raised to power m is equals to, we can rewrite 16 as base of 4. That is 4 raised to power 2, then bracket minus 1. Then from here, you are having your 4 raised to power m to be equals to, this implies that 4 raised to power m is equals to 4 raised to power minus 1 times 2, that's minus 2. Now you can see from here too, the base are equal. Then you are going to equate the powers. Equate the powers. So when you equate the powers, what will you have? You're having m to be equals to minus 2. M is minus 2. Now, doing it the other way around, we can as well solve this by considering the second approach that we apply then. That means you will see that the 0.0625 has been solved to be 1 over 16. So we can rewrite this as log 0.0625 base 4 to be equals to log 1 over 16 base 4. 0.0625 has been solved or evaluated as 1 over 16. Now, you can now have log 1 over 16 base 4. That's log 1 over 16 base 4 can be written as log, that's 16 raised to the power minus 1 base 4. And it can go further as log 4 raised to the power minus 2 base 4. And applying the law of logarithm that we said, that when you're having log m raised to the power p base a, we said is equal to p log m base a. So applying this to what we have here, that means this is equal to minus 2 log 4 base 4. And we know that log 4 base 4 is equal to 1. So this is equal to minus 2 times 1. And that answer is minus 2. Which is the same thing with what we have here, as you can see. So you can see the way we have solved this and the other method that we have applied. We are still going to apply the same method in solving the third question. Now for number C, what we have in number C is log 32 base 8. Now you can say it the same time that let log 32 base 8. Now you can say this, let log 32 base 8 equals to p. Now, let's see how we are going to get the value for p. So, express this in index form, as we can see from what we've done so far in the other examples. So, we are going to have 8. 8 is our base. Raised to power p is equals to 32. 8 raised to power p is equals to 32. This is now in index form. We can rewrite 8 as the power of 2, and we can write 32 as the power of 2. Then we are going to have 2 raised to power 3p to be equals to 2 raised to power 5. 2 raised to power 5 is something as 32. That means we are multiplying 2 in 5 places. So if we have 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. That is it. And we're having 1, 2, 3, 4, 5. That's why you have 2 raised to power 5. 2 in 3 places. That's why we have 8. That means 1, 2, 3. If you are having this like this, 2 times 2, 4. 4 times 2, 8. That's why you have 2 raised to power 3. And p is here already. That's why you have it. From here, you can see that the bases are equal. Since you're having the same basis, then you can equate the powers. So you can also say the same thing, equate the powers. When you equate the powers, what are we going to have there? We are going to continue from this aspect. Equate the powers there, we are going to have what? And that's going to be, you're having 3p to be equals to 5. Now, the coefficient of p here is 3. So you are going to say divide both sides. Divide both sides by the coefficient of p, and that is 3. So you're having 3p divided by 3 equals to 5 divided by 3. 3 cancel 3, then you're having p to be equals to 5 over 3. So that is how you solve that. Or you can say it's 1 whole number 2 over 3. Still the same thing. So you've seen, you've got to your answer. And if you want to do it the other way around as well, we can apply that concept. Now, let's see how we are going to solve it using the other method. Now, in this case, you could see that there is no way you could express 32 to the base of 8. So we are still going to use the same method of expressing 32 to the base of 2 and expressing 8 also to the base of 2. Now, there is a principle that we want to explain in that case. That means when you're having log 32 base 8, now we can simplify 32 to the power of 2, and that's going to be log 2 raised to the power 5, and 8 also is going to be log 2, the base is going to be 2 raised to the power 3. You can see the power is having the base, and the base is also the power, the number is having a power, and the base is also having a power. So in this case, I want to introduce something to you here, which I want you to understand. Now, when you're having log m base a raised to power p, if the base is having a power a raised to power b, now in this case, it's going to be log m 1 over b log m base a. Now let me repeat that again. Now when you're having log m base a, and a is not having a power, the power of a is b. So if you want to write this, is the reciprocal, that is 1 over b log m base a. 1 over b, that is the reciprocal of the base. 1 over b log m base a. That is how you solve that. So applying this in solving your question, that means we are having 2 raised to the power 3 here. We've explained the fact that when the number is having the power, it's going to come direct. That is 5 log. So, and in the case of the base, you are going to have it this way. So if you want to apply what we have here to now solve or to complete that question, you are going to see it here. And how do you see that? Here you are having log 2 raised to the power 5, then base 2 raised to the power 3. Now, like I said, the 5 is coming here. It's going to be 5 log 2 base 2 raised to the power 3. Now, the base having a power is what I've explained here. That means this is going to be 5 times, this is 5 times 1 over 3 log 2 raised to the power 2, as you can see. So 5 times 1, that is 5 over 3 log 2 raised to the power 2. Then log 2 raised to the power 2, we all know that it's going to be 1. So this is going to be 5 over 3 times 1. So the answer is 5 over 3, which is the same thing with what we have here. As you can see, whichever method you are using, either the first method or the second method, you are still going to get the same answer out. So let's see how we are going to solve the fourth question. I hope you understand this method of solving it. Now let's solve it also with the same method. That's the fourth question. We are having log this d 0.5 base 32. Now we are going to simplify this in fraction. That's 0.5. Then you are going to have it as log 0.5 is 1 over 2. And this is what? 32, base 32. As you can see, we are going to rewrite this as log 2 raised to the power minus 1. And 32 can be expressed as 2 raised to the power 5. Now, apply the same concept that we have explained in the previous question. Let me just repeat it again for emphasis. That means when you're having log m base a raised to power b. Now, the base is the one having the power. This is going to be 1 over b log m base a. So we are going to apply this while solving this question. So when you're having log 2 raised to the power minus 1 base 2 raised to the power 5. So it's going to be, now we are having the minus here. So you are going to be minus 1 over 5 log 2 raised to the power 2 base 2. That's log 2 base 2. Now, the minus is the one that is account for this negative. Then this 5 is 1 over 5. as you can have it here. So log 2 base 2 is equals to 1, and this one gives us minus 1 over 5 times 1, and that is minus 1 over 5. And that's how you solve the question. Direct that way. And the same thing, you can see apply the first method that we have applied before. And in that case, when you're having log 0.5 base 32, now you can say let 0.5 log 0.5 base 32 equals to x. Now the base is here 32, log 0.5 base 32 equals to x. If you want to write it in index form, you are going to have it as 32 raised to power x equals to 0.5. 32 raised to power x equals to 0.5. Then let's see how we are going to complete that in this case. Now, in that case, you are going to have 32 raised to power x is equals to 0.5. Express 0.5 as a fraction. That means you're having 32 raised to power x is equals to 1 over 2. And from here, you're having 32 raised to power x is equals to 2 raised to power minus 1. You can write 32 as the power of 2. That's 2 raised to power 5x equals to 2 raised to power minus 1. Then from here, you can see, how do you solve this question? Since the base are equal, equate the powers. Equate the powers. And once you're able to equate the powers, what do you do there? You're having 5x equals to minus 1. 5x equals to minus 1. Divide both sides by the coefficient of x. And the coefficient of x is 5. So you say divide both sides by 5. So you're having 5x over 5 equals to minus 1 over 5. This cancel this. Then you are seeing that x now, x is equals to minus 1 over 5. So still the same method that we've used before, we still get the same answer with the other method. Then we have the next question to answer. And as this junction, you can actually pause the video and see how you can attempt the other question yourself. Just 2 other questions remaining. But meanwhile, let's see what you are going to get when you solve it after pausing the video. When you pause the video, you answer the question, then let's see what your answer will be. So in that case, I'm going to solve the next question. That means I'm having log 128 base 0.25. And like I said, you can actually say that let this equals to y. Log 128 base 0.25 equals to y. And if you want to express it in index form, that means I'm having 0.25 raised to power y equals to 128. Can you see that? 0.25 raised to power y equals to 128. Then I'm going to express my 0.25 in fraction, and that is over 100. So that means I'm going to having 25 goes here 1, 25 goes in 100, 4. That means I'll be having 1 over 4 raised to power y is equals to 128. I can simplify this as 4 raised to power minus 1, then raised to power y equals to 128. That's 2 raised to power 7. That means 2 in 7 places. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, that's 128. Then I can rewrite this as 2 raised to power minus 2 y equals to 2 raised to power 7. Now, when you say 2 multiplied by minus 2 times y, that's 2 raised to power minus 2y equals to 2 raised to power 7. From here, you are going to equate the powers. And when you equate the powers, then what are we going to have? You're having minus 2y equals to 7. Divide both sides by minus 2. That's the coefficient of y. So you're having minus 2y divided by minus 2 equals to 7 over minus 2. Minus 2 cancel minus 2. Therefore, y is equals to minus 7 over 2. And that is minus 3, 1 over 2. And have it that way. Then the last but not the least there is you're having log root 128 base 2 root 2. Now you are still going to do the same thing. In this case, you can say let log root 128 base 2 root 2 to be equal to n. And if it's equal to n, how do you going to solve that? Remember, this is your base. That means you are going to have here 2 root 2 raised to power n is equals to root 128. Root 128. 128. So from there, how do you solve this? Now, we can say that, how do you solve this? Let's solve what is in this bracket. And in that case, in the bracket here, you're having 2 dot root 2, then raised to power n. And this is 128 raised to power 1 over 2. So you're having here as 2 dot 2 1 over 2 raised to power n will be equals to, when you simplify this, we are going to have this as 2 raised to power 7 raised to power 1 over 2. So from here, this is 2 raised to power 1 and half. So 1 and a half, 1 plus 1 and a half. That's having 2 raised to power 1 whole number 1 over 2 raised to power n to be equals to 2 raised to power 7 over 2. So from here, if it's 2 times 1, 2 plus 1, 3. So what are we going to have in that case? You are going to have it that's 2 raised to power 3 over 2n equals to 2 raised to power 7 over 2. 2 raised to power 7 over 2. Then, when you clear this bracket now, that means you're having 2 raised to power 3n over 2 is equals to 7. 2 raised to power 7 over 2. Equate the powers since the bases are equal. So you're having 3n over 2 equals to 7 over 2. Now we are having 2 and 2 here as the denominator. We can cancel that. 2 cancel 2 here. So you're having 3n equals to 7. From there, you can divide both sides by the coefficient of n. Divide both sides by 3. In that case, you're having 3n over 3 equals to 7 over 3. 3 cancel 3. Then from here, you can see n is equals to 7 over 3. So you can see what we have and how to solve that, and you can express it further. That's 2 whole number 1 over 3. That's how we solve this question. We solve question based on evaluating logarithm. So likewise, if you are new to this channel, ensure you subscribe. Please subscribe so that you can get more questions as you upload more videos. And if you have any question, even as regards this or in other aspects of your mathematics that you are finding difficult, or probably even in other subjects, science subjects, art subjects, and commercial subjects, if you are having any challenges in any aspect, send the comments into the comment section below. And the links to other videos will be seen in the description below. Ensure you liking this video, you subscribe to this video, and you share this video to get more notification when other videos have been uploaded and to get more knowledge in your various content. We are starting this for all students, for you to enjoy and to have a well understanding in your mathematics.